So welcome back, guys. Today we'll see about the thermometry. So thermometry, first I will give the concept, afterwards I will write some solutions. So thermometry means it is a part of one of the part in thermodynamics. Is one of the part in thermodynamics. So here we will study about 2 points. In thermodynamics we will study, one is temperature, so another one is heat. So whereas coming into the study of temperature is called thermometry, whereas study of heat is called calorimetry. So temperature, so here temperature is effect and heat is cause. So coming into temperature is measure of heat, means which gives direction of heat flow. So we know heat is a form of energy. So now we can tell the heat is a tensor, not a scalar. It is tensor quantity. And the temperature decides the direction of flow. It is form of energy. The direction of heat flow will shows the direction of heat is given by temperature. The temperature flow from hot body to cold body. So if you see the hot body means the which one have more kinetic energy. Which one have the more kinetic energy. That means the heat can be heat energy can be less, but having the more kinetic energy, it is called hot body. I hope you understand. So an example I will give you. So the one body's heat energy is equal to, so one body heat energy Q1 and another body Q2. So this Q1 have energy 500 joules or calories. So Q2 have 600 joules. But in this kinetic energy is equal to 200 joules. Potential energy is equal to 100 joules. And other forms means vibration energy is equal to 150. So other forms is equal to 50. The total 500. So this is the distribution of energy, heat energy in these forms. So heat energy not only one form, means it is not only in kinetic energy, not only in potential energy, means it is a form of sum of all the energies. So here in this kinetic energy is equal to 150 joules and here it is 200 joules. So this is again 150 joules. Other form is equal to 100 joules. So total 600 joules. But here heat energy is Q2 is more than 500 joules. But coming into compared to this value, so this one 500 joules is hotter body. The 500 joules will be hot. Then this is cold. Means hot body depends on its kinetic energy. That means kinetic energy proportional to temperature. So this one activity is there that and all you can study later. So now the temperature measures by a thermometer. Thermometer. So in this thermometer mainly there are types are there. The types of means thermometric property. The thermometric property is means pressure can be means you can measure pressure, volume, density, resistance, so and so on. So coming into so this temperature measured by the property which is called that means substances all matter otherwise matter heating expands on heating. This is the property of thermometer construction. So there are types. So types of thermometer. Coming into types, first one is liquid thermometer. The second one, gaseous thermometer. Third one, resistance thermometer. The fourth one is resistance thermometer. Value means gaseous thermometer only again parts are there. Means different parts are there. In the gaseous thermometer, platinum resistance and thermometer, thermoelectric thermometer, radiation thermometer. So the radiation thermometer and vapor pressure thermometers. So there are main types. These are the main types of thermometers. Vapor pressure. So in liquid thermometer, alcohol thermometer, again here types coming into here two types are there. So in these two types, one is in the liquid thermometers are two types. One is mercury and another one is alcohol. So whereas mercury thermometer ranges are -50 to -50 degrees centigrade to 350 degrees centigrade. So here I will explain later what is degree centigrade scales. Degree centigrade means the scale measure of temperature in scales. Alcohol thermometers are more or less, that is -80 degrees centigrade to 350 degrees centigrade. So this is value of measurement. In gaseous thermometer, hydrogen gas thermometers are there, nitrogen gas, helium gas, whatever the gaseous thermometers, and constant volume thermometer, constant pressure thermometers. So there are that type of thermometers in gas. In the resistance, platinum resistance thermometer, thermoelectric thermometer, radiation thermometer. Now the radiation thermometers means pyrometer. Instead, this is pyrometer. So which is used to measure the high temperatures up to 6000 degrees centigrade. So example, surface of the sun. Surface temperature of the sun is that is 6000 degrees centigrade. So like that high temperature to measure the radiation thermometer will use. So here vapor pressure thermometers. So this is variation of temperature with constants. So that will discuss in the types, right? So in all the thermometers, thermometric property is expansion. Means all these are gaseous, resistance, expansion. So how will say that expansion of thermometers means? So let's come to this property. I mean this is so X is the thermometric property. So X naught is thermometric property at 0 degree centigrade. And X100 is thermometric property at 100 degree centigrade. So Xt thermometric property is at T degree centigrade. Means in the place of X we can write. So pressure you can write, volume you can write, density, resistance, and length also you can write. The length of mercury like that. So now this can be written as so xt means x naught is equal to some x unknown value into 1 plus alpha into 0. So x100 is equal to, so means x naught is the initial temperature at 0 degree centigrade. So x naught into 1 plus alpha into 100. So xt is equal to x naught into 1 plus alpha into t. So here alpha is coefficient of linear expansion. So coming into these two, from these two equations, 1 and 2, x100 by xt is equal to 1 plus alpha into 100 by 1 plus alpha into t. Similarly, from these two equations, x100 minus x0 is equal to x0 into alpha into t. xt minus x0 is equal to, sorry, this is x100 minus, means x0 alpha into 100 this is. So this is x0 into alpha t. Therefore, I want to t to calculate. T is the temperature. So the temperature, the where these values are given, temperature is equal to xt minus x0 by x100 minus x0 into 100. So here you can substitute thermometric property pressure at constant volume, at constant the volume, the P is varies with respect, P is rises with P proportional to temperature. Gelug-Shakala in gaseous laws will study. Therefore, T is equal to Pt minus P naught by P100 minus x naught into 100. So in this place, in the xt place, whatever you can write, volume you can constant pressure thermometer. So then volume, constant pressure thermometer means pressure is constant, there V proportional to T. So therefore T is equal to Vt minus V naught by V100 minus V naught into 100. So here x naught means 0 is x naught, 0 degree centigrade. This 0 is called ice point. The 0 is called ice point. So everybody know what is ice point. So 100 is boiling point. Ice point is nothing but, so where the state changing from solid to liquid without changing the temperature. Temperature is constant here. That is called ice point. So here the heat given or heat required to achieve this state of change is called latent heat. That in calorimetry we will study. So similarly, so liquid to gas means boiling, liquid to gas. So where the substance is changing from liquid to gas without changing its temperature. The temperature is constant, but the state is changing from liquid to gas. That is called boiling point. At what point? So ice point, boiling point. This is only afterwards they called as lower fixed point. So lower fixed point and upper fixed point. So in the scales of temperature, I will explain this. So the thermometric property can be written T is equal to Pt minus P naught by P100 minus P0. The same way xt minus x naught by x100 minus x0. That means x naught into 100. This is general formula of thermometer. Or this is also the general formula of representation of thermal property at respect to temperature. Okay, x100 is the temperature at 100. xt is at the temperature T. xt thermometric property. x0 is thermometric property at ice point. So I hope this way of presenting the thermometric property to find out the temperature by the values you understand. So in the resistance you can place. So whereas coming into scales of temperature, scales. In the scales, first one is degree centigrade Celsius scale. The second one is Fahrenheit scale. Degree Fahrenheit will measure. That is Fahrenheit scale. So if any spelling mistakes means don't consider that. I am very poor in spellings. Fahrenheit. So third one is Kelvin scale. So everybody know this is absolute scale also will call. Absolute scale of temperature. Absolute scale of temperature. Why means it is no negative temperatures. no negative temperature, and the 0 Kelvin is equal to minus 273 degrees centigrade, and so and remaining also. So we can measure whatever the temperature in Kelvin scale with whatever the temperature, positives and negative we can measure. Coming into remaining scales, Reimer scale and Rankine scale. So we can't measure them, measure negative temperatures. So that is the reason we are using Kelvin scale as absolute temperature. Whatever the low temperatures also up to minus 270 degrees centigrade you can measure. Up to now, no substance is maintaining minus 273. The research is going on this thing, right? So how to convert the one scale means temperature conversion of temperature. Next one is conversion of temperature. Conversion of temperature. So coming into conversion of temperature from one scale to another scale, that is equal to C minus LAP by UAP minus LAP. So is equal to F minus LAP by UFP minus LF. So that equal to K minus LAP by U minus L. Similarly, R minus LAP by U minus L. So here this is Reimer. So this is Rankine minus LAP by UAP minus LAP. So upper limit minus lower limit. Sorry, upper limit not means boiling point minus ice point. So here if you take Celsius scale, if you take the Celsius scale, so when thermometer is placing in, for example, this is the thermometer. So there is a capillary inside, small capillary. So when you are placing this in ice water, so here ice. So when means mercury rises to one level, mercury rises to one level and stop there until the total ice melts. Total ice melts. The reading of thermometer one level it stops. That is equal taken as ice point at 0 degree centigrade. And the same thing we are placing in, same thing is placing in boiling oil or water, boiling water. So the mercury stands up to this level. So 0 degree centigrade, this is 100 degree centigrade. So total water will be steam converting into steam, then this 100 degree centigrade level will not increase. That means the 0 degree centigrades are called LFP and 100 degree centigrade point is called upper fixed point. So like this, the remaining scales also have same Celsius scale, Fahrenheit scale, Kelvin scale, the Reimer scale and Rankine scale. So coming into LAP, UAP, and number of divisions between this means this is divided into parts. So each part is equal to here 1 degree centigrade. So here LAP is equal to 0, UAP is equal to 100, divisions also 100. So coming into Fahrenheit to 32, 212 and 180. Kelvin 273.16, 373.16, 100. So Rankine is, Reimer is, the Reimer scale is 0 to 80. The Reimer 0 to 80. So 80 divisions. So this is 492 to 672, 180 degrees. So if you see clearly here, if we see this table clearly, the rise of temperature in Kelvin and centigrade scale is same. Whereas Rankine and Fahrenheit scale is same. The Rankine and Fahrenheit scale are same. So therefore, the rise of temperature means here from this table I am going to conclude some point. So 1 degree centigrade is equal to 1 degree rise of temperature in 1 degree Celsius is equal to rise of 1 degree of Kelvin. So 1 degree rise of centigrade is equal to 1.8 degrees of Fahrenheit. So 1 degree rise of centigrade is equal to 0.8 Reimers. So like this, that means 1 degree centigrade is greater than 1 degree Fahrenheit. 1 degree Fahrenheit. That means 1 degree centigrade is equal to 1.8 Fahrenheit. So 1 degree is greater than 1 degree Fahrenheit. So now in temperature scale conversion, for example, I want to convert my body temperature 36.9 degrees Celsius. So I want it is in Fahrenheit. We well know that is 98.4. So we'll see this comes or not. So therefore, when conversion of 1 degree to another degree, so C to F I am going to convert C to F. Therefore, 36.9 minus LAP 0 by 100 is equal to F minus 32 by 180. So this is 9, this is 5. So that implies 36.9 is equal to 5F minus 160 by 9. So 9 will come this side. 36.9 into 9 plus 160 is equal to 5F. So this is, you will get 9 9 is 81, 9 6 is 54, 72, 9 3 is 34 plus 160. So that equal to answer is 3581 by 5 is equal to Fahrenheit. So it is approximately, so 35.8 something is coming. So 160, 27, 27, this is 34 only, correct? 36.9 into 9, 9 3 is 27, okay. 532, yes. It is coming wrong. 2 minutes. Yeah, calculation mistake. This is a point will come here. So this 342.1. So 160 adding means, so that is 402.1 is equal to 5F. So 5F. So this is 50. 50.21. F is equal to 52 by 5. 5 9 ja. This is approximately 2 10 50. So 9 5s are now 5 ones 0 and 1 0 0.42 degree Fahrenheit. So 36.7 means maybe it will be answer 98.4. So 36.9 or 37 means answer is, this is 100.4. Then 100 Fahrenheit. And here this is conversion of scales. So C is equal to 5 by 9 into F minus 32, or F is equal to 9C by 5 plus 32. Means from this you can say F1C graph. So here slope with slope 9 by 5 and plus C plus 32. So this is F, this is C and F graph. So we'll start like this. So this is 32 and the slope is equal to 9 by 5. So I hope you understand this. So this is F and C graph, means Y equal to mx plus C, F equal to 9C by 2. If you take C and F graph, so 5 by 9 is slope, but minus 32 will come. So that is like this. So here F you consider, F1, so here C on Y axis consider, F1 X axis will go. Because C is equal to, slope is 5 by 9 in F times mx, C is Y, Y equal to mx, M is equal to 5 by 9. And 5 by 9, 160 by 9 is the slope, right? 160 by 9 minus 160 by 9. This is, so like this. So this is C and F graph. This is F1C graph. This starting from plus 32 and the slope is 9 by 5. Here also slope is 5 by 9. This is 5 by 9 slope. Tan theta is equal to 5 by 9. Here tan theta is equal to 9 by 5. So this is graph for C and F. Coming into C minus 0 by 100 is equal to K minus 273, lower fixed point, 0.16 by 100. So therefore C is equal to K minus 273. That means here C and K graph. So Y equal to mx plus C, here M is equal to 1, slope is equal to 1. So it is starting from minus 273. So like this. Y equal to mx, slope is equal to 1. Here slope is equal to 5 by 9, same, minus 160 by 9 is the point. Here it is minus 270 is the intersection and Y equal to mx plus C. If we go with K and this graph, so K on x axis, this is C on Y axis, K on x axis. So I will go with K on x axis, C on Y, means C on x axis, K on Y axis. That means K is equal to C plus 273. Here mx, so x is equal to C, Y is equal to K, therefore Y is equal to 1 into x plus some coordinate. So that is, so here onwards it will come. So y equal to mx, slope is equal to like this. But here it is 273. So this is the answer. So this is K and C graph. This is C and K graph, C and F graph, and F and C. So you can understand this. So whereas nowadays we'll write with a triple point. So this ice point, boiling point. So instead of that, all temperature scales we are measuring with a triple point. Therefore, coming into triple point, let's consider Tk is represented at Ax, means Tk is the temperature at 0 degree centigrade, and at any temperature K, right? So at normal means 0 degree centigrade means 273.6, 273.16 degree for kelvins. So that is equal to, we'll go with Axn. So that is equal to something x. This is xk you can consider. This is A into x naught. So therefore, Tk is equal to temperature in kelvins is equal to. So division these two, this is equal to xk by x naught. A get cancelled into 273. Xk by x naught into 273.16. So now this x is the thermometric property. At any temperature in kelvins, Tk is equal to A into xk. At 273.16, not 0 degrees, 0 kelvins. At 273.6 kelvins means that is reference line x naught. Thermometer property is x naught or 0 degree centigrade. So this is triple point representation of any thermometric point. Here you can go with the pressure, the volume, resistance, like that. So this is about the thermometry. So here only one important case, that is, so writing the thermometric equation, general equation of thermometry, T is equal to xt minus x naught by x 100 into 0, and conversion of temperature scale. Some bits will come on temperature, heat, and how the temperature and kinetic energy, energies are related, is scalar or vector, like that. So now I will go with some formulas here. So if you see clearly, this is the question is given, graphs lines are given, and Fahrenheit and degree centigrades are given. So in any one of means in the graph they can change here degree centigrades, here Fahrenheit, but all the lines are same they have given. This is the B line, this is the D line, this is A line, so this is C line. But scales, temperature scales on x-axis and y-axis is different. So now if you consider these points, so this is C, comma 0, F value is 0. So at the C value, the F value means any C positive C value, this is the positive C value, the F can be 0, so not possible. This point is not possible. Therefore, these two lines, C and A lines, are not at all possible. Right? So now coming into this point, F value something and 0 degree centigrade. Yes, this point is possible. That means 0 degree centigrade means 32 Fahrenheit. So this point is possible. But C is equal to positive. Where C is equal to positive means 1 degree I will take. Then automatically F is equal to 33.8 degree Fahrenheit also, right? So that means there is no zero value. Zero Fahrenheit 0 means centigrade should be negative. So this point is possible again, because this is centigrade is minus, but Fahrenheit is 0. So that is 0 Fahrenheit means, so 0 Fahrenheit is equal to, C is equal to 5 by 9 into minus 32. So that equal to minus something, it is 160, minus 160 by 9. So that is equal to 149, 1 ja 9, it will not go to 70. So nearly it will come 118 degrees. 0 Fahrenheit is equal to minus 180 degrees centigrade. So like this will come. So this line is possible. So now this point means this line, these 2 points are exist means B line is possible. So now these 2 points exist or not, we'll see. So here this is F is equal to negative, but C is equal to 0. C is equal to 0, F is equal to negative, not possible. So this line is not possible, this A line is not possible, C line is not possible, B line is possible. So coming into F and C, same like that. Here this is F comma 0, this point is possible. And here 0 comma F, this point is not possible. 0 comma degree centigrade means 0 Fahrenheit, but positive degrees, not possible, not exist. C 0 means 32 Fahrenheit has to come. C positive means it will be more than 32 Fahrenheit. But there will be 0 Fahrenheit and some value of positive C is not possible. So that is the meaning here. 0 Fahrenheit and some positive values of degree centigrade is not. This point is like that only now. So this point is not possible means this line not possible, and this line also not possible. So this is possible, this line. So now we have to see now this one. Here negative minus, so negative degrees, negative Fahrenheit. Then 0 degree centigrade is not possible. At 0 is minus plus 32. So negative means it will go down, right? So negative only will come. Negative Fahrenheit means degree centigrade also negative only. So there is no possible. This point is also not possible. So this point is not possible means this line is not possible. This line automatically not verified not possible. So only one A line is possible. So this is understanding. And slopes are simply slope. If we take means already this is C on y axis. C is equal to slope f by 9 into f minus 32, f minus 160 by 9. So mx plus c, mx minus c. So this graph only exists. If you verify means directly you can verify these values and all known in data. So whereas coming into this also same c ones. So minus, right? So here f and c is given. Therefore f is equal to 5 by 9 into c plus 32. So that graph is plus value. It will start from plus value. So that is this, right? This graph. So this line is possible. Slope is 5 by 9. And the intersect is positive intersect. See here. This is the positive intersect. And here this is the negative intersect in this case, right? So I hope you understand this graph how to classify. The same way here also down they have given, see. So those two already explained in the concept. So whereas coming into another questions here. So this question is a graph, see. This is the lower fixed point of x degree scale, and Raymer scale is equal to given 40 degrees up to 40 degrees, but this is the Raymer scale. So upper fixed point is equal to 80. So now according to this graph I will write, so x minus of minus 20 means x plus 20 by, so see here this is the upper fixed point and this is the lower fixed point 60 is equal to x minus 0 by lower means lower fixed point in the Raymer equal to 0 by 40. So now x value is equal to 5 degrees of Raymer's will come. So he's asking to convert into this 40 degrees timer, convert into kelvins. He's asking the value in kelvins. Therefore, K minus 273 by 100 is equal to R minus 0 by K minus 273 by 100. General formula is equal to R by R minus 0 by 80. So R equal to 40. If you do, you will get 323 kelvins. Simply here given this graph also same like that. Slope is finding and values are given, upper fixed point and lower fixed point. So I have taken the points 32, 0 and 212, 100. Otherwise, from the graph, we can go C by F. That is the slope of that one equals C by F. That equal 5 by 9 is coming there. So if you follow like this also, you will get points and finding the slope. Slope means y2 minus y1 by x2 minus x1. Equation is equal to that line equation is equal to y minus y1 is equal to the line equation. Y minus y1 is equal to slope into y2 minus y1 by x2 minus x1 into x minus x1. This is the line equation of 2 points, which is passing through the 2 points x1 y1 and x2 y2. So from the graph, given graph, I will take the 2 points. So this is x1 comma y1 and this point is x2 comma y2. So now x2 is equal to 212, y2 is equal to 100 and here x1 y1 is equal to 32 comma 0, right? So this is x1 comma y1, this line. So now we can go on. If here a negative value is given, means that you can take not any 2 points you take. These 2 points are these 2 points, you will get the line equation same only. Extending the line means straight line, you can extend any point. So this is one type of question. So now one scale we are using accurate Celsius scale and a Fahrenheit scales. So Celsius scale reads 60 degrees and Fahrenheit scales read 141 degrees. So respectively. So correction in the Fahrenheit they are asking the question. Correction in the Fahrenheit they are asking means there is a mistake in the Fahrenheit scale, right? That's why the centigrades convert. This is the centigrade is correct. So accurate Celsius scale and Fahrenheit scale showing the readings like this. That means this 141 is the wrong because they're asking correction in the Fahrenheit scale. 141 is not correct value. So 60 is the accurate value. So convert 60 degrees into Fahrenheit first. So F equal to n by 5 into, if you do one, you will get 140, right? You'll get 140. So this, but 140 is the exact value for 60 degrees centigrade should be given by Fahrenheit scale also. But how much is giving? 141 degrees is given by the Fahrenheit scale. So 1 degree mistaken. Sorry. So this is thermometry property RT, R10, R100 and RT is given. So you can find out alpha and substituting the formulas. This is R0 is R10, R10 is equal to R0 plus R0 into 1 plus 10 alpha into 10. That means R10 minus R0, R10 minus R0 by R0 into 10 is equal to alpha. That equal to R100 minus R0 by R100 into, so R100 into 100. So R0 into 100. So that is equal to RT minus R0 by R0 into T is equal to alpha. This is alpha value. So already in thermometric property we have given RT is equal to by R0 into alpha. So we equate this any one equation by substituting R values, you will get alpha value, and substituting you will get 60 degrees answer. Right? Oh, but R0, R10 is given, R0 is given. Therefore, the T can come 70 degrees, 60 plus 10 degrees. So it is not starting, this equation is not starting from 0. So this is T is equal to 60 plus 10, 70 degrees will answer. So similarly, the one more model like that same. So they have given 521.5 degrees at one temperature scale, means one the value. In this question, constant pressure thermometer as the values 525.1 at T degree centigrade and 273.2 at 100 degree centigrade. It is T degree centigrade. This is 100 degree centigrade. This is 0 degree centigrade. So we know temperature at any temperature for any thermometric property is equal to xt minus x0 by x100 minus x0. So here in the place of thermometric property is given pressure. The values with respect to temperature they have given, that I substituted. Similarly, in another scale of temperature, resistance is given. So this is resistance at T degree centigrade, 0 degree centigrade like that. So the difference in these two scales here, if you solve this equation, we will get 4. So they have given this value is, here the value is coming because of this at a temperature is given 440.1 x degrees is given, but I got 444.1 I will take. So then x is equal to 4 value is coming. Similarly, in this value they have given answer 420.6 plus y degrees centigrade is given. They have given in degrees centigrades. So actually I got 421.6 I got. Then y is equal to, subtracting means y, 1 will come. Difference between 420.6 and 421.6 is equal to 1. The asking x plus y is equal to, actually these are the answers, but for testing the knowledge and mathematical something will be there in a scientific attitude. So for that and all they are giving like these questions, application, checking your math knowledge also. So here 444.1 came, but they have given 440.1 plus x, and here already this is over, this is the answer. They are giving 420.6 plus y is equal to y, then x plus y is equal to asking. Means you have to convert these values according to what they are going to test you in examination, right? So these are one type of testing. That's enough. One skill, it will comes under one of the scientific skill, right? The next model, freezing points is given for one thermometer scale, and boiling point also given. So temperature of 340, that reading, that scale is giving temperature, so which is in terms of equal to the 340 kelvins. So first of all, so here I want to tell one statement is, the general equation in any scales, the general equation is equal to x minus LFP by UFP minus LFP, faulty thermometer or a correct thermometer, whatever, this value is constant. Means x value means temperature, that the scale is giving the temperature minus LFP by UFP minus LFP is equal to constant. So this is the reading of thermometer is given. Whatever the thermometer you are using, the same reading they have to give, but the values are different. For example, my body temperature is in degrees centigrade I am measuring me 36.9. Fahrenheit I am measuring means that will be 98.4, 100.4 will come. Means 100.4 I found, but 98.4 has to come. That is 36.9 or some other value like that. So whatever in centigrade or Fahrenheit, the reading number will change, but both are showing the same by temperature. Means it is faulty thermometer or lower thermometer, the rising of mercury should be same. Means the reading as given by measuring the mercury length should be same. That has to give the same quantity of temperature of the body. So that's why x minus LFP by UFP minus LFP. This is constant in all the scales. You can keep here C, you can keep here Fahrenheit, you can keep here Rime or Rankine or resistance, whatever that is, faulty thermometer reading value, whatever. So now the similar on this only, this question I'm going to base, So Y scale, this is the scale of Y consider. The scale Y is having freezing point, means lower fixed point. This is lower fixed point, and this is upper fixed point. And it is giving the temperature equal to 340 Kelvin. Therefore, Y plus minus of minus plus 160 by freezing minus upper fixed point minus lower fixed point 110 is equal to 340 minus 273 by 100. So we'll get like this. So finally we'll get answer is 83.6 minus 83.6. So in this only one more value. So same y scale is given. So which is equal to 50 degrees centigrade. Here 50 will substitute, means how much will come? Y plus 160 by 110 is equal to 50 by 100. That equal to 1 by 2. So that equal to y plus 320 is equal to 110. Therefore 2y is equal to minus of 210. So that is equal to 105. So minus 105. So this is the temperature. Okay. Same scale, but in here that reads 50 degree Kelvin, 50 degree centigrades. But that in this question 340 kelvins it is reading. So then for the y value, the correct reading is in the y scale they are asking. So that is minus 80, 86.3 degrees of y. So in centigrade it is equal to 50 degrees, measuring means the 50 degrees is equal to the temperature of 50 degrees centigrade in y scale is equal to y minus LAP by UAP minus LAP. So that is the reading of any scale. The any scale gives the reading this by this general formula, x minus LAP by UAP minus LAP is equal to constant in all the scale. So now they are given graphs here in the next question. This is another model of question. See once. A thermometer graduated means that will be to a linear scale. Graduated means readings are given scale. What we'll call liberated. Some language they will give liberated and graduated or calibrated. Again, calibrated maximum it is correct. Calibrated to a linear scale reads the value x naught. When in contact with boiling water means reads a value x naught at ice point. A boiling point of water x naught by 3. The reads x by 2. Then x value is how much? Then t is equal to formula what? Xt x by 2 minus x naught x by 3 x minus x by 3. So x at 0 degree centigrade, x 100, x naught by 3 at 0 degree centigrade boiling water, right? So x by 3 minus this much, you will get 25 degrees. T is equal to x naught is x by 3, x 100 is equal to x at 100 x by 3 is x naught. So this is x at 100 degrees centigrade. This is at ice point, and x naught by 3 at ice point. This is the reads x by 2 at any temperature, some T temperature. The question is incomplete here. So x degrees at boiling point in contact with boiling water, x by 3 contact with ice point, and reads at x by 2 means some temperature. At some temperature the value is x by 2. So therefore is asking to find out the temperature is how much. So 25 degrees. It can be degree centigrade or degree Fahrenheit because it's not mentioned. It is which scale of temperature. So 25 degrees of that scale, representative scale. So this is another model. So now coming into this value, KMI means which one of the best representation is graph you have to calculate. So nearby one is the answer. So this is the answer, right? This one, because y equal mx plus c, and here the c value is plus 2, c value is equal to minus something is coming 5f by 9. So it will be positive only will come. So this is the answer, slope, positive slope, 5 by 9 positive slope. All are positive slopes only. This is also positive slope only, but negative value is coming here. Negative of this is k and f, negative k, but your answer is positive intercept. So this is a positive intercept, right? Like that. So next questions. So here this solution, see, so easy only, nothing here. X is equal 10t square, where t is in degree centigrades. So x equal to 10t square, then t is equal to 273 plus c. Degree centigrades means 273 plus kelvins will change. So here x equal 10t square. So t is in degree centigrades and capital T in Fahrenheit. Kelvin, sorry, capital T in kelvins. Therefore here capital T I can go. T is equal T minus 273. Then T square is equal to T square plus 273 whole square minus 2 into K into 273. So now X is equal to 10 into T square. What I got here? Capital T square plus 10 into 273 whole square minus 540 into T. So now this is compared given AT square plus BT, because A minus B whole square expanded, plus C. The C value this is, the A value 10, then B value is equal to, is given minus 5460 into T. But here again 54656, that equal to X value is how much? 4 degrees. X is 4%. So coming into here, they have given like this. This is a general equation. So at triple point means T value is equal to 273 point. So here you can substitute this. R is equal to R naught into 1 plus something alpha, you go with alpha into 273.16 minus T naught. Similarly, 165.5 ohms at normal melting point here is given. So this R value is given. Here R value you have to substitute. So in this you have to substitute the T value. And the temperature when resistance is this much is asking to find out. Therefore here 165.5 is equal to R naught into 1 plus alpha into. So this is 600.5 minus T naught. So here this is R value is given 101.6 ohms. Therefore 123.4 is equal to R naught into 1 plus alpha into temperature is asking to find out T minus T naught. So we know already this subtracting alpha is equal to formula, you are alpha equating all alphas already, resistance R10, R100, R99 you have done RT. So same like that you are doing means you will get answer. So this is about thermometry and some related problems totally have given. Next video I will do expansion solids. Thank you.